Okay, 3x squared plus y dy along the line. So the line given is A is 2 and 3 to B basically is 4 and 7. So in this case here, so if you were to draw contour into your plane, xy plane, so your contour started out from A is x is equal to 2, y is equal to 3. Ended up with x is equal to 4, y is equal to 7. Okay, so it's actually just a straight line, alright? Okay, so this one, you can actually try it out. I mean, this will be a maybe an easier one for us to try it out. But nonetheless, okay, so what happened here is you're given this path, this contour that we need to actually integrate starting from 2, 3 to 4, 7. And what we need to do is we need to work out the relationship for this straight line. So based on the relationship that's given, we know that the gradient is going to be what? The gradient is going to be 7 minus 3 divided by 4 minus 2. So this will give us 2. So as a result, this relationship is going to be y is going to be equal to 2x. Okay? 2x plus 1. Right? When x is equal to 2x, is it 2x plus 1 or 2x minus 1? Okay, 2x minus 1. So 2x minus 1 will be the line that we have actually worked it out. Okay, so once you've done this, you can actually come back here because you're integrating it with respect to y. Right? You're integrating it with respect to y. So what you need to do is you need to change whatever you see inside here that is actually x to y for integration purpose. Okay, so making use of this straight line relationship, y is equal to 2x minus 1. So x is going to be equal to y plus 1 divided by 2. Okay, so what's going to give you for x squared? X squared is going to be equal to y to the power of 2 divided by 4 plus 2xy. 2xy is going to be equal to what? 2xy is, if we were to work it out, okay, so 2y divided by 2, so it's going to be y, okay, y divided by 2, right? Because when you square this, okay, when we square this, so square it, this becomes a y squared, this becomes a 4, so 2y divided by 2, 4 is half, and then plus 1/4. Okay, so now your integration from 0 with respect to y, we look at our starting point is actually 3, the ending point is 7. So we integrate from 3 to 7. Okay, we integrate from 3 to 7. And when we integrate from 3 to 7, so you have 3 times your x squared, so you have 3/4 of your y squared plus 3/2 of your y plus 3/4 plus y dy. Okay, alright. So of course the rest will be just quite straightforward in the integration. So evaluation just with the limit. So this will be y cubed plus y squared. So it's 3/4 y squared. Okay, plus 3/4 y plus y squared divided by 2, and then this is basically 7, 3 to 7. Okay, so of course you need to basically work it out. So this is actually 1/4, 7 to the power of 3. It's going to be what? 3/3, and then minus your 3 to the power of 3 is 27. Okay, so likewise for this, it's going to be 3/4. 7 squared is 49 minus 9, and then this one is going to be 7 minus 3 is going to be 4, 3/4 times 4, and then the last one is going to be again is half of your 49 minus 9. Okay, so this is 40, this is 40, this one is going to be 343, 27 is 316, right? 316. So 316 divided by 479. Okay, and then this is 3/4 of 40 plus 30 plus 20 from here, and then plus 3. So what do we get? You get, and I missed, okay, 50 plus 179, 50 plus 179 is 129 plus 3, 132. Okay, alright, so this is how we do it by integrating it with respect to y. Okay, so we can actually change it because why? Because from the line equation here, y is equal to 2x minus 1. So if we were to try to find the relationship for your differential with respect to y and x, you can actually see that dy is actually equal to 2 dx. Alright, y is equal to dy is equal to 2 dx. So as a result, if we come back to this integration, dy is equal to 2 dx, and what is y? Y in this case here is actually quite straightforward, right? So you have 3x squared plus 2x minus 1. Okay, and then dy, change it to 2 dx. So as a result, so what happened here is you have a 2 and then dx. So this is your line integral also. So originally this is a line integral. So now if I'm to integrate it along the x direction, so your x, basically the lower limit is 2, the upper limit is 4. Okay? So what I'm trying to show you is sometimes a problem, if you integrate it with respect to x versus respect to y, one way is actually easier than the other. Okay? Alright, so you should still get the same answer. So this one becomes x cubed plus x squared minus x. And this is basically evaluating it from 2 to 4. Okay? So we have 2 times your 4 to the power of 3 is 64. Right? Plus 16. 64 plus 16 minus 4. Okay? And then minus 8. And minus x squared, 2, right? Okay, so minus 4, and then when you substitute 2 is minus 8, and then when you substitute 2 is minus 4 plus 2. Okay? So in a way, you see this will cancel out this. Alright, so what you get here is you get 66. And you ended up with 132. So, the whole idea here is to show you that, right, in the question, you are free to change, interchange. You can actually interchange. Okay, not too much of a problem. Okay, you can actually free to do some interchange between your x and y integration. Okay, any question with this? Alright, okay, let's take a look at your example 8, because one thing that is important that I want to show you all in example 8. Okay, so try to attempt your last question, right? Question number 3 and 4. Okay, so try to do number 3 and 4. Let's take a look at example 8. Example 8 is also quite interesting in the sense that, so what we are looking at for your example 8, again, is a line integral, but it is not, sometimes it's not direct in the sense that you can actually have a line integral with respect to a function that actually has dx and your dy actually both showing up. Okay, so let's take a look at question number 1. Evaluate the line integral. So we are asked to evaluate the line integral 2xy dx plus x squared dy along the arc C of the circle x squared plus y squared is equal to 1 in the first quadrant. From A is equal to 1, 0 to B is equal to 0 to 1. So it is actually moving in a counterclockwise direction, and then explain your result. Okay, so what we can actually do in this now, we are given this line integral to actually work on. So the line integral is 2xy dx plus x squared dy. Okay, and then we are asked to integrate it along the arc. Alright, so point A is 1, 0, and then point B, so it's in this direction, counterclockwise direction. So this is your x, this is your y. Okay, so the circle is given with this relationship x squared plus y squared is equal to 1. And we are basically in the first quadrant. Then of course, based on this relationship, straight away I can actually write x squared is equal to 1 minus y squared. Okay, I can actually write it that way. And of course, okay, all right. So we have this relationship, and we also have, in a way, because here you're integrating it with respect to x. That means I need to change y, right? I need to change y to something that is actually easier for me to work with. So you can actually see that, okay, so you have y is going to be equal to square root of 1 minus x squared. Okay? Alright? But is it necessary for us to basically replace it that way? Well, you know, I mean, it is a way that you can actually explore. Okay, so we'll just go through and then we'll see what will happen. If we were to follow what the question basically asks us to do, integrating it with respect to x or 2xy, and then integrating it with respect to y or x squared. Okay, we work through the question. So if we were to follow the line integral in that aspect, so this will be, because of x is basically 1 to 0. Okay, so what you have here is you have 2x, the square root of 1 minus x squared, dx plus for y, because y in this case here, x squared is equal to 1 minus y squared dy, so it's actually straightforward. So this will be from 0 to 1. Okay, so in a way, if you were to try to differentiate this, will be a little bit tedious, right? Because I mean, integrate it, you have a square root of 1 minus x squared, and then you have a 2x outside, then you're multiplying the whole terms, and then you're integrating it with respect to x. So what you need to do is a substitution method, right? So I hope you still remember your substitution method. So if we were to let u equal to 1 minus x squared, so what happened here is your du then is going to be equal to minus 2x dx. Okay, so from this expression here, we can actually see that, well, 2x dx actually equal to minus du. Okay, so in this equation here, this will be 1 to 0, And then 2x dx minus du, so this is basically square root of u, right? Because u is equal to 1 minus x squared. So now, square root of 1 minus x squared can be written as u raised to the power of half, and then it's a minus du. And of course, the second portion of it, straightforward, because you can actually try to integrate it. So what you have here is you have y minus y cubed divided by 3 and 0 to 1. Okay? Alright, so in this integration, of course, what you have here is you have u raised to the power of half, so it becomes u raised to the power of 2/3 divided by 3 over 2, right? So 3 over 2 becomes minus 2 over 3. And then we are evaluating it from, you need to actually change the limit, right? So this one, actually, we need to change the limit because when x is equal to 1, okay, when x is equal to 1, so you have to remember to change the limit because just now we did change. So when x is equal to 1, what is your u? U is equal to 0. When x is equal to 0, u is equal to 1. Alright? Based on u is equal to 1 minus x squared. When x is equal to 0, u is equal to 1. So we need to actually change it. So this should be 0 to 1. Okay? So this will be 0 to 1. And then plus, of course, here, what you have here is y is equal to 1 minus 1/3. Okay? In this expression here, we are integrating it from 0 to 1. So what you get here is you get minus 2/3. And then here, what you get here is you get 2/3. So when you do the contour integral or your line integral, you actually ended up with 0. Okay? You actually ended up with 0. Alright? So, I mean, they ask you to explain the result. Well, you just ended up with 0. There's nothing unusual, right? It's actually possible. It depends on how your function is going to be like when you carry out the line integral. Okay, what I'm going to point out to you is if you come back to this portion of it, the integral of 2xy dx. Okay, so we can actually do it differently, right? We can actually do it differently because we are given this relationship x squared plus y squared is equal to 1. So can I actually try to find out the differential relationship? So you can actually try to work it out from here. You have x squared plus y squared is equal to 1. So as a result, you can actually write 2x dx plus 2y dy is equal to 0. Alright? 2x dx plus 2y dy equal to 0. So, okay with that? So as a result, so what is your 2x dx? 2x dx is going to be equal to minus 2y dy. Alright, based on what we have actually worked out from here, from the original. So you always fall back onto what is given to you as far as the contour is concerned. So in this case here, the contour is a semicircle. X squared plus y squared is equal to 1. So from x squared plus y squared is equal to 1, if you try to find out the differential relationship, you have 2x dx plus 2y dy equal to 0. As a result, 2x dx is going to be equal to minus 2y dy. Okay, so what we are trying to do here is, if you remember, originally, I is equal to 2xy dx, right, plus x squared dy. Okay, so we did the integration, right, by substituting in 1 minus y squared and so on. So we have actually done that portion of it, and this portion of it is going to give us 2/3. So now we try to tweak it. So I'm just showing you, maybe it can be easier for you to work on in exam. So by substituting 2x dx with minus 2y dy, so you ended up with what? You ended up with minus 2y squared dy. Okay, so now you are integrating, you are changing it, you're changing the whole thing from an integration with respect to x to an integration with respect to y. So you need to actually change the limit, because why? The limit is actually starting from 0 and ended up with 1. Okay, so if you were to integrate this portion of it, so you ended up with minus 2 over 3 y cubed. And you are evaluating it from 0 to 1. So what will this give you? This will also give you minus 2/3. So you can actually see that combined with what we have actually worked out on the second part, which is actually 2/3, your answer is still going to be the same. Right? You're actually getting the same answer. Okay, so what I'm showing you is basically sometimes you don't have to, the question basically stated, integrate this portion with respect to x, another portion with respect to y. Do you have to rigidly follow? No. You can actually make use of a contour relationship. Seeing the contour relationship, you can actually make use of them and simplify the question for your integration, yes. But of course, if you're going to ask me that from here and you say, okay, if I have to change this, right? If I have to change this to the y, and I'll tell you that the answer will come out different. Because why? We explained before, okay? Originally, taking a function, integrating it with respect to x is a projection onto your exact plane. If I have to change this to dy, I'm taking the same function along the contour, but projecting it onto your yz plane. And of course, the answer will be different. Okay, you will expect different answers. Alright, so this is one thing that in the homework that is quite interesting. Okay, the other one is, I think I want to show you is question number 2. Is it question? Let me see. Is it question? Yeah. Question number 2. So question number 2, why is question number 2 interesting? Because you can actually see that question number 2, basically, when you work it out, question number 2, when you try to do your line integral, right, from point 0, 1 to 1 and 2 of y squared dx plus 2xy dy. Okay, what we are trying to show you here is they are actually what we call exact differential. Okay, question, if you look at the question didn't actually ask you, but the question actually asks you to try to work it out. Show that the line integral is independent of the path from 0, 1 to 1, 2, right? The coordinate is 0, 1, and 1 and 2. Evaluate the integral using 2 different paths. So that's what the question asks. Okay? So we will do that, but along the same time, what we will try to do is we will show that, well, is this an exact differential? If it is an exact differential, what can we actually try to find out? Alright? So first, you have this y squared dx plus 2xy dy. So what is your y squared? If you still remember when we discussed about your exact differential, this is your pxy, right? It's actually equal to y squared. What is your pxy? This is your del f del x. Okay, then also you have your del f del y. Del f del y is actually equal to 2xy and it's equal to q of x and y. Okay, so how do we actually show that this is indeed an exact differential? If it is indeed an exact differential, that means if you were to differentiate the second derivative, right? So if you have del 2f, del y, del x, for this instant is going to be equal to 2y, and then of course the other one is going to be del 2f, del x, del y is also equal to 2y. Okay, so in this case here, you can actually show that the second differential, right? The second differential of the function, they are actually equal, right? That means what we have shown is del p del y is equal to del q del x. X. Okay, sorry, this is x. Okay, so that basically implying that this is an exact differential. Because we did mention that if your function is an exact differential, so what happened? If function is exact differential, it should be path independent. That means it doesn't matter which path you take. All you need to know is the starting point and the ending point. Okay? So if this function is an exact differential, we have your del f del x is equal to y squared. So what is your parent function? Your parent function is going to be equal to y squared dx. Right? So from here, I can actually work it out. What is the parent function? The parent function is going to be y squared x plus gy. Okay? And then we mentioned that your q is actually del f del y. So if I take this function and I do del f del y, so what do I get? I get 2xy plus g prime y. And then what is your qxy or your del f del y is actually equal to 2xy. Okay, so this is actually from the top here. So what does it imply from this two differential? Del f del y is equal to 2xy. Del f del y is equal to 2xy plus g prime y. So what does it imply? Your g prime y is equal to 0, right? Because it should not exist. I mean, it should be equal to 0. If g prime y is equal to 0, then what is your gy? Gy is a constant. Okay? So from here, immediately we can actually work out what is the parent function. The parent function is just going to be y squared x plus a constant. So this is your parent function, or you can actually write it as such. Okay? Alright, so we will come back and check to see whether this path independent thing correlate well with our exact differential and so on and so forth. Okay. Next thing is, because we are doing this path independent, we are looking from a path from 0, 1 to 1 to 2. Okay, so if I have to draw it, so the starting point is x is 0, y is 1. So this is 1, this is 0, and then the ending point is x is 1, y is equal to 2. So it is here, right? So you can actually see that. So this is a path. Okay? And of course, this path, if you try to integrate it, it depends on whether you want to play around with it. You need not, right? So this one, basically, if you were to work it out, the slope is going to be equal to 1. So this is basically y is equal to x plus 1. So this is the line, your contour relationship. Okay, that's your contour relationship. Okay, so now if we were to carry out your line integral, okay, so if we were to very quickly try to work it out, okay, so this is along the x-axis, and this is actually along the y-axis. So if this is a starting point A and this is an ending point B, okay, you have a starting point, you have an ending point B. So what we are saying here is, moving from A to B, I can actually move directly from A to B. I can also move along the x-axis and then along the y-axis. So this basically shows you that we are indeed taking two different paths. Okay, the whole idea here is, if I have to move from A to B, it's a direct path. If I can move from A to A prime and then to B, then it's a second path. Okay, so of course, because this actually is a straight line, so straight line, of course, I mean, you try to move it along, the whole idea of moving along the y-axis, and then along the x-axis, and then the y-axis is primarily, if you move along this direction, so what happened? There's no change in your y. If there's no change in your y, you don't have to evaluate the integral, right? If you are moved from a to a prime, so what happened to your dy? dy is going to be equal to 0 because your starting point and your end point is going to be the same. But if you move from point A prime to B, you can actually see that what happened to your x. Your dx is not going to change because your dx is actually at 1. Starting at 1, ending also at 1, except that the y has actually changed. So if we were to take a look of this integration, you can actually see that, okay, coming back. So this is our line integral. So the first point, you're starting now. Okay, so you can actually see that if I have to move from A to A prime, so I'm moving from x from 0 to 1. So 0 to 1, so initially I have y squared dx. Okay, and then of course, when I move along this direction, as I mentioned, I have my 2xy dy, but because my y is from 1 to 1, so as a result, I can actually cancel it out. Okay, and then come to the second part. So this is basically a to a prime. So now if I move from a prime to b, so this is going to be from a prime to b is going to be 1 to 1 y squared dx plus 1 to 2, right? So this is actually 2xy dy. So again, when you move from a prime to b, so this is actually a prime to b. So what happened here is this term actually gets cancelled out. Okay? Alright? Yes. Which one? Here. Right? Because because when I move from A to A prime, from here to here, your x will change. Your y actually maintain the same. Right? When y maintain the same, you try to integrate it because your upper limit and the lower limit is going to be the same. So when you integrate it, you substitute the upper limit and the lower limit. Since they are the same, they will cancel out each other. The equation on top is path from A to A prime, and then we move from A prime to B. Okay? And then of course, in our equation here, what do we get here is you are working with y is equal to x plus 1. Okay? You're working with y is equal to x plus 1. So as a result, okay?
No, I didn't get it. Sky, you understand? No, but the first part, if you say this is exact differential, then you're supposed to integrate the second part also, right? How come he immediately get the parent function y squared x plus c?
Because earlier on we have the relationship y is equal to x plus 1, then of course you can actually see that you need to actually go through all the derivation. Okay, but of course, can you take the shortcut out? Yes, as we mentioned, always making use of the line relationship, right? But here basically what happened here is you are moving, okay? You're moving from what we have done is we are moving from y squared dx. Okay, so the first portion of it is actually y squared dx. So what we need to do is we need to basically change it. Okay, we need to actually change it. So what we can actually do is we can actually change it in a way that here your x is actually so in our case here you can actually see that if we go back okay, y is equal to x squared, so this becomes x squared plus 2x plus 1 dx. Okay, and then the second portion of it plus 1 over 2. So this is actually 2xy dy. Okay, so you have y is equal to x plus 1. So this becomes x is equal to y minus 1. Okay, so you have 2 of y squared minus y dy.
I got it.
Okay, all right. Okay, so from here, what you ended up with is you ended up with x cubed divided by 3 plus x squared plus x 1 0 0 to 1, and then on the other side of this, what you have here is you have a 2, so you have a y cubed divided by 3 minus y squared divided by 2, and this is basically you know, taking it from 1 is to 2. Okay, so you have 1/3 plus 1 plus 1 plus 2 times, so this one, if you have y cubed for 2 is 8 over 3 minus 2, right? Because y squared divided by half, so it becomes 2, and then this will be minus 1/3 plus half. Right? Plus half. So this one is going to be equal to 1, 2, and then 1/3, so is 6, 7 over 3. Alright? 1/3 plus 1 plus 1, 7 over 3, and then plus. So from here, so what you have here is 8 over 3 minus 2 becomes 2 over 2, 2 over 3, 2 over 3 minus 1/3 is still going to be 1/3, 1/3 plus half. 1/3 plus half is so this is 7 over 3. Okay, minus 6 over 3. Plus 3 over 6. Okay, so this one is going to be what? This one is going to be 1/3. 1/3 is going to be 2, 6, right? So it's 5, 6 times 2. So it's actually 5 over 3. Okay, all right. So what do you get? You get 12 over 3. Is equal to 4. Okay? Alright? Okay, so this is how we integrate it. Okay, so this is basically A to A prime, and then from A prime to B. Alright, so very quickly, I'm going to show you, if I have to move directly, so a bit impatient, so I just move directly. So what will happen if I move directly?
I think she does approve. Yeah.
Mentioned we can actually move directly, right? So if I have to move directly, how would I actually do this? So originally your integral is y squared dx plus integral of 2xy dy.
He beat around the whole bush.
Okay.
And now you still
Alright. So what we're saying here is I can, if I have to move directly, I'm actually moving from A to B. So this is 0, 1. So this point is 0, 1. This point is 1, 2. Okay, so if I want to do it, if I move it directly, so what happened here is I can actually, for simplicity, because why? Because if you were to look at the first equation is y squared. So from the line, y is equal to x plus 1. What is your dy? dy is actually equal to dx. So I can actually very quickly change this. So this becomes y squared dy. So when I change it to dy, the limit is actually from 1 is to 2. Alright? And then of course, for the second portion of it, if we were to change it, because this is dy, so it all depends, we can actually change it to dx also. Right? So this becomes 2x. Your y is x plus 1 dx. And then of course your x, you're integrating it from 0 to 1. Alright? I mean, we're not changing anything. We're just basically following the integration and carry out. So in this case here, you got y cubed divided by 3. Evaluating it from 1 is to 2. And then the other one is going to be 2 times your, because this is your x squared plus x. X squared plus x, you ended up with x cubed divided by 3 plus x squared divided by 2. Alright, the 2 will still going to be there, and then this will be 0 to 1. Agreed? Okay, so this is actually just a direct integration. So if you were to put in the evaluation and all that, so this one will give you what? This one will give you 8 over 3 minus 1/3. Right? Because you substitute y is equal to 2, and then the second portion of it, what we're going to get is going to be 1/3 plus half. Okay, 1/3 plus half, so it's going to end up the same thing that we are looking at. So 1/3 plus half is going to be 5 over 6. Okay, so this one is 8 over 3 minus 1 over 3, so this is equal to 7 over 3. Plus 2 times 5 over 6. So 2 times 5 over 6 is going to be 2 times 5 over 6. This will give you 5 over 3, and you ended up with 12 again. So you can actually see that if you were to integrate it directly from the path of 1 to A to B, you actually get the same answer. 4. Yeah. Thanks. Okay, so you get 4. Okay, the last one, if you remember earlier on, we said this is exact divided by 3, sorry. Okay, the last part of it, earlier on we mentioned when we work it out, what is the parent function? The parent function is equal to y squared x plus constant. So this is a parent function that we worked it out earlier on. So if you want to do, as we mentioned, if it is going to be path independent, that means your line integral is going to be equal to your parent function, substituting it at, so this will be x of b, y of b, minus your function at x of a, y of a. Correct? Okay, so now if you were to go back, you have y squared x. So this is actually originally is 0, 1. And this is 1 and 2. Hey, the other way around. 1 and 2, and this is 0.